Welcome to this tutorial on the means by which the cerebellum serves to modulate movement. This topic pertains to several of our core concepts. You're tired of hearing me say this, I know, but once again, I need to remind you that the brain is indeed the body's most complex organ, and that much of the basic function that we are learning about, especially in this unit of the course, pertains to circuitry that is under genetic determination. Now, that's not to say that this circuitry cannot be modified through our experiences in life. Indeed, that's the case. And as we come to the cerebellum, we come to a part of the brain that is especially involved in responding to our life experiences. And in a different tutorial, I hope to show you a rather dramatic example of one such paradigm that induces a dramatic change in the function of the cerebellum that we can watch happen in real time. So stay tuned for that. So I'm going to break this tutorial down for you into three parts. In this first part, I'd like to speak to you about just the basic parts of the cerebellum and provide for you an overview of cerebellar function. And then in the next part, we'll look more deeply at the circuitry of the cerebellum, including the inputs and outputs of the cerebellum. And then finally, we'll talk again at the end about cerebellum function. And then I'll talk to you a little bit about the signs and symptoms associated with dysfunction of the cerebellum. So our learning objectives for this part of the tutorial are, first of all, to identify and to discuss the basic parts of the cerebellum. And I want you to be able to characterize in very general terms the major functions performed by the cerebellum. Now, before we say too much about the cerebellum in terms of its structure and function, I want to just highlight what has been sometimes called over the years the enigma of the cerebellum. And the enigma is that the cerebellum is one of the brain's most recognizable structures, and yet its function has been mostly elusive over these many decades that modern neuroscience has now been trying to discover the functions and operations of cerebellar circuits. It has a beautiful circuitry, as I hope to show you shortly, but the functions have been much more difficult to understand. Part of the enigma is that we know, unfortunately, from people that have had damage to the posterior part of the cranium, that destruction of the cerebellum leaves one still able to walk, to talk, to think, to see, to touch, to feel, to have a more or less normal emotional or cognitive life, but yet there is dysfunction. And so the enigma has been, how can such a massive part of the brain be damaged and produce seemingly only modest impacts on neurological function? Well, I think we perhaps know a little better now. Certainly we know more about the function of the cerebellum, but I think we're a little bit more sophisticated in our analysis of human performance and certainly in clinical care. So I think what we would say now is that yes, the impact of cerebellar dysfunction can be subtle, but it can be quite significant, and it certainly can have a significant impact on one's sense of self and one's sense of engagement in the communities in which we live. So there is a role for the cerebellum that's important, and it's one that we need to understand. And that will be the focus of the third part of this tutorial. So just keep in mind, the cerebellum is a massive brain structure, yet its functions have been somewhat enigmatic to understand. Well, let me try to resolve this enigma as best I can by just discussing with you in broad overview the function of the cerebellum. Well, in a phrase, the function of the cerebellum is error correction. And when we think of what it takes to actually do something difficult or to learn a new motor task, acquire a new skill, perhaps perform a new piece on a musical instrument that you may or may not be very familiar with, or perhaps it's a new dance. Whatever kind of skilled motor behavior you can think of, there is an element of motor learning that's involved. And essentially, the essence of motor learning is implementing error correction. So the way the cerebellum does this is that it integrates executive commands about the intentions of our movements with sensory feedback about the way our body is actually moving. And it's this integration of executive signal and sensory feedback that gives rise to moment-to-moment corrections of behavior and performance. These functions facilitate learning when the errors are numerous. And if you'll recall the last time you tried to do something challenging or difficult with the movements of your body, especially involving your distal extremities, you know that there are a lot of errors, but it's through the experience of those errors that we can accrue skill. And it's that motor learning process that engages the circuitry of the cerebellum. Now, one key point that I want you to appreciate about the organization of the circuits of the cerebellum, we'll come to this in the second part of this tutorial, is that the cerebellum does not engage the lower motor neurons directly. In this sense, it's similar to the basal ganglia, which also did not engage lower motor neurons directly. Rather, the output of the cerebellum is directed towards circuits of upper motor neurons. And one important means by which the cerebellum will do so is by interacting with the thalamic nuclei that send projection to the motor cortex. A little bit more on cerebellar function. This might help you. I know it helps me. I like to think of the cerebellum as an organ of agility. And I want you to think about agility in the broadest possible terms. Think about anything that you can do with your body that you consider to be agile. Or maybe it's not movement of the body. Maybe it's movement of the mind. Maybe it's movement of thought. Maybe it's problem solving. Maybe you're really good at solving crossword puzzles, or you're very gifted in mathematics, or you're just a very logical, inductive sort of person, and you can reason your way through challenging mental problems. If that's you, then probably the cerebellum has contributed to your capacity to move your body or to move your mind with agility. So we want to account for how is this possible? Well, with respect to movement of the body, one component of agility involves the coordination of multi-jointed movement. So movement across multiple joints, often in a precise sequence of movement, sometimes from proximal to distal, although there may be some movements that work in the other direction. Now, I'd like to extend this concept of agility into the domain of cognition and imagine that the connections that the cerebellum maintains with circuits that engage the prefrontal cortex also operate in the same way as those circuits that engage the motor cortex. And from this standpoint, perhaps it's useful to think about mental problem solving as a kind of coordination of sequence. Or if we want to think of the various components of problem solving as movement across multiple hinged joints, if you get the metaphor, then I think we can understand the cerebellum as being involved in the coordination of multi-jointed cognitive processes. That is, cognitive processes that articulate and that are sequenced in very much an analogous way as the movements across multiple joints of a limb. Okay, well, that's my introduction. I want you to understand some of this background as we now seek to identify the basic parts of the cerebellum. Well, there are really three basic parts of the cerebellum that we want to consider. There's the cerebellar cortex, which is all of this massive tissue that we see from the surface view of the brain. In addition to there being an outer cortex, very much like a cortex of the cerebrum, there are deep nuclei that are buried down in the depths of the white matter of the cerebellum. So if we were to peer down into the core of the cerebellum, right along the roof of the fourth ventricle, we would see some gray matter, and these are called the deep cerebellar nuclei. So the gray matter of the cerebellum is organized into two tiers of processing. There's an outer cortex, and then there's an inner mass of deep nuclei. While the cerebellum is connected to the brainstem via three large stalks of white matter, and we call these peduncles, the cerebellar peduncles. So the cerebellar peduncles are the third major component of the cerebellum that we want to orient ourselves to. And there are actually 3 peduncles that come together near the central lateral region of the cerebellum. Those 3 peduncles are this large, massive middle cerebellar peduncle, by far the largest of the 3. And just on the superior aspect of that peduncle, we find a superior cerebellar peduncle, and that is this structure that is shown here in this purple color, the superior cerebellar peduncle. This is largely a pathway that gets information out of the cerebellum down just on the medial and inferior edge of the middle cerebellar peduncle. We find the inferior cerebellar peduncle. So the middle is the largest. It's conveying signals from the brainstem, specifically the pons, into the cerebellum. The superior is a way to get signals out of the cerebellum, and the inferior peduncle is a bit more bidirectional than the other 2. It is dominated, I think, by inputs that are going into the cerebellum, mainly from the spinal cord, but there are also connections that are going into the cerebellum from the brainstem via this peduncle, and there are efferent signals coming out of the cerebellum through the inferior peduncle. So we'll have more to say about this when we talk about the inputs and outputs of the cerebellar circuits.